Hi, in this video I'm going to demonstrate 3D scanning this flywheel using Creality Sermoon P1, and then I'm going to compare the workflow and the result with the Simoon X1. I will make two scans, front and the back side, and then I will align it together by using automatic marker alignment function. The scan object is medium size and it has a lot of area to put on the markers. So I won't be using the external marker. I'm starting the P1, choosing the close line mode and set the resolution to 0.25 millimeter. This cast iron flywheel is weight more than 10 kilos, so I can't put it on my 3D print turntable. In the single line mode, I get about 60 frames per second, and for the cross line, I get somewhere around 40 to 50 frames per second. When I pause the scan, I can zoom in for inspection because the 6 inches screen is very small comparing with my monitor. Okay, next I'm making a new scan. This will be the scan number 2. Okay, next I will finish the scan. And then I will use the lasso tools to remove the table so that the table won't block the view when I reposition the scan object. Okay, now all the table is removed. Okay, next I'm going to reposition the flywheel so that I can scan the bottom side. I'm not making a new scan. I will use this function called continue scanning. And it will just start where you left off. That simple. This is the reason why I don't use external markers in this scan, so that I can do continue scanning in different positions. Before I do the point cloud fusion, I will delete the table first. The scanner will has less point cloud to compute and finish the fusion quicker. It has all the selection tool as in the Creality Scan, except for the single body selection tool, which is the new tool. I hope that they will add that in the P1 as well. The include lasso tools work well. I don't have an issue selecting the point cloud using my fat finger. Okay, next I'm going to do batch fusion. Okay, so the first scan has 1.8 million triangles, and I need to trim out the noise from the marker. This happens when you place marker too close to the edge. Okay, next let's try automatic alignment with the marker. Because I don't use external marker, so I can do this. It will align to scan together using the overlap marker on the side of the wheel. So if you are using the P1 on the job side, you can fuse the point cloud and try to align them to see if you need to do the rescan before you left the job site. Right now I have 3.6 million triangles, so I will mesh them using 3.7 million faces. And here's the mesh result. It will give the same quality as when you do it using the computer. Okay, I'm going to import this and compare the result with the X1. Okay, import complete. This one is from the X1. This one is from the P1. It's fused and meshed within the scanner. Because the P1 mesh export within the scanner is not ready yet, so you need to export to the PC and then click on the export model to export into the OBJ or point cloud format. Okay, let's try to scan this with the X1. This time I use different approach. I scan with the global marker, scanning on the both sides of the flywheel. I don't recommend you doing this with the heavy object because it might slip out of your hand and fall down from the table. Once all the markers are scanned, I can then scan the point cloud on both sides of the flywheel in just a single scan without merging. Now I'm scanning the front side. The cross line from the X1 has a larger capture range than the P1. Next, I'm going to delete the table so that I can reposition the flywheel without the table blocking the viewport. The scanner will recognize the pre-scan markers, so you don't have to align the scans if you are using this approach. Okay, let's try single body selection tools. Just one click and you select the separate body. That's one improvement from this version 4.1.7. I have 2.7 million triangles. Okay, let's take a look at the scan quality. On the right is X1 and on the left is the P1. Scan at the same resolution, 0.25 millimeter resolution. So it's give pretty much the same result except for the accuracy, of course. The X1 will have a higher accuracy. They give the same smoothness on the surface. And this is cast iron. Okay, let's turn to the back side. Okay, so it's give pretty much the same result. If I don't tell this one is the P1, this one is the X1, it's distinguish the resolution between these two scanners. So it has the same standard for Creality scanner. When you set at the same resolution, you pretty much get the same result. Even with the S1, a Raptor Pro, or the P1, same result exactly. The review sample that was sent to me, I used it in my first review video, and I just found out that the sample that they sent to me is not a retail version, it's a pre-production sample. Okay, this would be the retail version of the P1. This has a better assembly quality, and they changed the rubber grip now. The retail version, it has a lizard skin rubber grip. That's a major complaint that I made. Prototype one, it comes with a very sticky rubber grip, and it's like a dust magnet. So if your hand is dirty or you are working in a garage, it's going to trap the dust and wear down very quickly. It's a good news that the retail version comes with this much better Lisa skin grip. It's not that sticky anymore, both front and back, and they have improved a lot of the hardware issues from the first version. Here's information that you should know